with rationalizing the denominator, what we're going to do is we're going to take sine and cosine and put those numbers together to make tangent, to do all the other operations we're going to learn about here in a minute. But before we get to that one, there's a small problem that we run into if square roots wind up being in the denominator. Square roots in the numerator is not a problem. Square roots in the denominator, there's a little bit of an issue because of just how things are set up and what we're going to do with that. Okay, so again, if you want to just write this on the back of this sheet, that's fine. I'm just doing this just to keep everything straight, because if I don't, the lines get crooked and then it's just ugly. So, all right, so when you rationalize the denominator, what that really means is you're going to eliminate all right, so the big thing is, again, we're eliminating the square root, the radical, from the denominator. And I'm going to give you the long way, then we're going to give you the shortcut you can do as well. So you're going to eliminate the radical from the denominator. And this is going to be, I guess we'll do the long part of here first, and then we'll show you the shortcut. So to do that, you're going to multiply. So eliminate the radical from the denominator by multiplying the numerator and the denominator by the radical in the denominator. Unless you're Doofenshmirtz, and it's in the denominator. All right, again, we're going to start kind of easy, and then we'll build up, because, and then we'll show you the shortcut you can do. Because a lot of times y'all may kind of catch up on the shortcut on this one, but if you don't, we'll show you what it was. Let's say you had 1 over the square root of 2, and they ask you to rationalize the denominator. All right, so according to this one, what we're going to do is we're going to take that problem that we have, and we're going to multiply, in this case, the square root of 2 is in the denominator. We're going to multiply the numerator and the denominator both by square root of 2. All right, top part becomes 1 times square root of 2, which is just square root of 2. We don't never have to do anything with the 1. The bottom part, 2 times 2 is 4, but the square root of 4 is 2. There you go. So if it's 1 over square root of 2, then that becomes square root of 2 over 2. And you may be, if you're kind of wondering why they do this, and it's really, this is kind of an old thing. I don't know how much longer they'll still teach it, but it's one of those things that with a lot of the calculators, especially with the Casios, you don't have to know how to do this. If you're using the calculators I've got over there with the Texas Instruments, those you still have to kind of know how to do this one. But basically, it goes back to a lot of the pre-calculator days up until about the 60s or 70s, that if you were trying to add and subtract with radicals in the denominator, it got really hard because you're trying to do stuff with square roots. Where if your denominator is just 2 or 3 or 5 or 7, it's a lot easier to work with it. So it's still one of those things where you're still going to kind of have to learn it, but it's more of the computers can handle it now, so it's not as big a deal as it used to be way back when. But, okay, so for this one, let's go with, just change up the numbers a little bit. Let's say it's 7 over square root of 3. Okay, so again, what we're going to do is we're going to multiply by the radical that's in the denominator, and then just work out what we can do here. So we've got 7 times the square root of 3 on the top. That's going to stay just 7 square root of 3. On the bottom, it's 3 times 3, so square root of 9. But square root of 9 is 3. And now, in that case, sometimes you can cancel from here to here, but 7 and 3 won't cancel. So it'll just stay 7 square root of 3 over 3. All right, now here's the shortcut. So that's technically what we're supposed to do. Here's what we're going to kind of do to kind of breeze through this a little bit. Basically, you just move square root of whatever that number is that we're doing from the bottom to the top. So we had square root of 3 on the bottom. Now square root of 3 is on the top. And then on the bottom, you're just going to get rid of the square root. So move the square root of number from the bottom to the top. And then take the radical off the bottom. So we had square root of 3. It just became 3. And you notice number 1, same thing. Square root of 2 went from the bottom to the top. On the bottom, we just took the square root off and just left it as a 2. Okay. So that's it's the same thing, but without having to go through all the steps. That's just a little bit of a shortcut that's there, but you can kind of go through. So if you had, let's do one here with a shortcut. Let's say you were doing 8 over the square root of 6. Okay, so without doing all the steps, we can kind of do the shortcut. We're going to move the square root of 6 from the bottom to the top. And on the bottom, you just take the square root off and just give me a 6. Okay, now I gave you this one because sometimes when you're working through these, you will get to the end. If you've got 8 over 6, that's the whole numbers. That part you could simplify it. So you could divide them both by 2, so you can make it 4 square root of 6 over 3. Okay, so if we had, 5 over the square root of 7, you can move the square root of 7 from the bottom to the top, and on the bottom, just take the square root off and leave it just as a 7. Okay, so if it's just one number on the bottom, that's the rational. Now, if it's a third root or a fourth root or a fifth root, there's something else that we have to do. But for what we're doing now, we're just going to worry about the square root part. If we get to the point eventually where we need to worry about the third or the fourth or the fifth root, we'll do all that. But if it's square roots, it's just that easy. That technically we're multiplying by the radical. Shortcut is, again, we're just going to move the square root from the bottom to the top and then just give me the number on the bottom. All right, now here's where we're going to go one more step with this one. So let's go back to, let me flash back to the unit circle here real quick. If we were doing, I'm going to complete a unit circle here. All right, so let's, and again, just kind of going back to this one. Let's say that if we had 30 degrees, or, we could go with 60. We could go with any one of these that we want to do. But do y'all remember what sine was? Or sorry, what tangent was? We said tangent was going to be which one over which one? Do y'all remember? All right, so tangent was going to be sine over cosine. All right. So for this one, let's say that we were doing 30 degrees. Again, if we were asking for cosine of 30, you don't have to necessarily write this down, just kind of watch for a minute. If we're doing cosine of 30, you go to 30 degrees, cosine would be the first number, so that would be square root of 3 over 2. If we ask for sine of 30, go to 30 degrees, that's the second number, that's the 1/2. Okay, so if they ask you for tangent, which is where we're going next on this one. If they ask you for tangent of 30, tangent of 30 would be sine of 30 over cosine of 30. We know that sine of 30 is 1/2. Cosine of 30 is square root of 3 over 2. All right, everybody okay with where we kind of went with that one? That if we were talking about 30 degrees, if you go to 30 degrees on the unit circle, cosine of square root of 3 over 2, sine of 30 would be 1/2. So if they ask you for, right now, this is the questions we've had so far. When I ask you to either find sine or cosine of 30, you would tell me the number. Where we're going next, and this is kind of what we're leading into today, is now we're going to ask you to actually find out what tangent is or some of these other operations. And if it's tangent, y'all said that tangent was just sine over cosine. So that's sine of 30 over cosine of 30. That's 1/2 over square root of 3 over 2. Yes, they lied to you. She just didn't tell you the rest of the story. You'll never have fractions over fractions until you get to high school. And then you have complex fractions. Okay, now here's the thing though. We've got a fraction over a fraction. We don't like the way that looks, right? Y'all remember what you had to do with the complex fractions way back when? No? Okay. All right, so here's what we're going to do. Yeah, but okay, this is 1/2 divided by square root of 3 over 2. All right, let's actually write it that way. Let's write it as 1/2 divided by square root of 3 over 2. All right, now we're thinking about it. If you had to do division with fractions, what did you have to do? What 3 letters? You had to. There you go. You had to keep, change, flip, right? So we're going to do that for this thing. We're going to keep it. We're going to change it, and we're going to flip it. Close. Yeah, KCF. Kentucky chicken fried. There we go. Okay. So we're going to make it 1/2 times 2 over square root of 3. All right, good thing with this one is 2's cancel, right? So it leaves us with 1 over square root of 3. Oh, but now we've got a square root that's in the denominator, right? So now we get to do our shortcut, right? We're just going to move that square root from the bottom to the top. And on the bottom, we're going to take the square root off and leave it just as 3. Okay, so that's kind of where we're going with this thing, is that when we're going to do sine and cosine and tangent, basically we're going to make them fractions with tangent part of it. You just got to, now again, it's okay if you get a number and the bottom number is just a number without a radical, you don't have to do this. But if you set up tangent and you get it so that after you do the keep, change, flip here, and you get a square root in the bottom, that's where you're going to have to rationalize this thing. And it's, don't want to say it's 50-50. It might be, actually might even be a little bit better than 50-50 when you're going through these. Just because of the way some problems are going to kind of work out for this thing. All right, so let me give you one more of those. Let's say you got 1 over square root of 2 over 2. All right, and again, if we rewrite it, that's 1 divided by square root of 2 over 2. So we're going to keep it, change it, and flip it. We'll get some Kentucky chicken fried. All right, so keep, change, flip. We've got 1 times 2 over square root of 2. The good thing is in this case is with the 1, it doesn't really do anything. It's just 1 times the number, so it's just 2 over square root of 2. But again, you've got this number on the bottom that's the radical. We've got to get rid of that radical, so we're going to shortcut it. So we're going to move the square root from the bottom to the top. Now, the 2 is already there, so that 2 is going to stay here, but we're going to move the square root from the bottom to the top. And then on the bottom, again, take the square root off and leave it just as a 2. But in that case, the 2's cancel. So eventually we get back to the answer being just square root of 2. Question, Daniel?
What if the 1 was on the bottom?
If the 1 was on the bottom, then you wouldn't have to worry about it, because then it's just over 1, and that doesn't affect the 1 at all in that case. So you can just leave it square root of 2 over 2. The only time you have to worry about, the rationalizing is that if you get the square root on the bottom, that's when you got to rationalize. If it'd been the other way, like you were asking, if it was square root of 2 over 2 over 1. If something's over 1, it doesn't really impact it, so you can just get rid of it. So that would just be square root of 2 over 2. And that's okay because the square root's in the top and not in the bottom. Okay, so now here's what we're going to do. We're going to take our newfound knowledge and we're going to flip over to the other side. And again, have your unit circle out so we can go through this. And we're going to go through and make sure everybody's okay with answering this parts and pieces here. And then we're going to tie it all together. Okay, so very first thing is we've got cosine of pi over 3. So we're going to make sure everybody's good to do this because this is going to walk us into where we need to be. Pi over 3 is right here. So what is the cosine of pi over 3? 1/2, right? So on your sheet, go ahead and put the 1/2 in there. What is the cosine, or what's the sine of pi over 3? Square root of 3 over 2. There you go. Radical root 3, square root of 3, however you want to say it there, square root of 3 over 2. All right, and hopefully you'll make the connection. If we go to pi over 2, what's the cosine value of pi over 2? 0. Sine is? So you're like, oh, so that's just the ordered pair. Yes, the cosine is the x value of the ordered pair. The sine is the y value of the ordered pair. So if we go to pi over 6, that's square root of 3 over 2, 1/2. If we go to pi over 4, yep, both same answers, both root 2 over root 2. Okay, if we go to pi, it's -1, 0. So cosine of pi is -1, sine of pi is 0. If we go to 330, the only difference when we get to 330 is that, again, now we're going below the line. So x will be positive, the y is going to be negative. So we got square root of 3 over 2 for cosine, and then -1/2 for the sine. All right, and again, when you get to the negatives, remember, for negatives, instead of going up to 45 degrees, if it's negative, you're going to subtract that from 360, right? So now we're going to go down 45 degrees, which should put you at 315. So when it asks for -45, that's really the same thing as being at 315 because we're doing -45. Because again, when we're talking about Tuesday, if you had a negative number to make it positive, we just added 360 to it. So if we add 360 to the -45, that's going to put us at 315. So that's the coterminal angles. These are the same angles, just one's going one direction, one's going the other, but we're still ending up at the same location. So for that one, that should be square root of 2 over 2, and then negative square root of 2 over 2. Okay. 7 pi over 6 would put us here, but it's -7 pi over 6. So that's really, if we do 7 pi over 6 or 210, -7 pi over 6 would be the same thing as -210. But again, if it's -210, yeah, we're going to add 360 to it. That should put us at 150. So, and here's the other thing you can kind of catch. If it's negative, positive 7 pi over 6 would be here. If it's -7 pi over 6, it's just going to be here. It's just going to flip across your x-axis if you go positive or negative. Just like when we did -45, 45 was here. -45, we just go across the axis. That's going to put us here. 210 was here. -210 will just put us there. So -210 would basically be the same thing as negative square root of 3 over 2 and 1/2. Okay, 720. Oops, sorry. There we go. Is not on the paper, right? But yeah, it goes around twice, right? So it's the same thing really as 0 or 2 pi, because if it's 720, if we subtract 360 from it, that puts us back at 360. So it's just going around the circle twice. We're still going to wind up back here, so it's 1, 0. Okay, and then 13 pi over 2. And you're like, okay, that is nowhere on the paper, right? Okay, but here's what you got to have to think about. You can do this in a couple different ways. This is 1 pi over 2, right? Pi over 2 is 90. If we did 2 pi over 2, the 2's would cancel, get us pi, that would be 180. So this would be 3 pi over 2. Everybody okay that 2 pi is the same thing as 4 pi over 2? But we just simplify to make it 2 pi. So this is 1 pi over 2. This is 2 pi over 2. 3, 4. This would kept going. This would be 5. This would be 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We could just keep going around and around and around if we count by pi over 2. What do we need here? We need 13. So that is, now the other thing you can do with that one, if you want to change that into like a mixed number, that's 6.5 pi's. So every time we go around the unit circle, every even pi is going to be here. Every odd pi would be here if we kept going round and round and round and round. So we need 6.5 pi's. So this would be 6 pi's to get us back to here. We need one more pi over 2, which would put us here. So basically, we're going to use this for sine and cosine. Okay, is everybody okay with how we got that one? Yeah, kind of. Okay, and it takes a little bit of practice. Once you kind of get used to it, you can either think, in terms of just sometimes it's easier to kind of do this to change it back to a mixed number. If it's 13 pi over 2, that's 6.5 pi's. And again, every time you go round and round and round in the circle, this would be 1 pi, 2 pi, this would be 3 pi, and this would be 4 pi, this would be 5 pi, this would be 6 pi. It just keeps going. If you keep going around, all the even pi's will be here, all the odd pi's will be there. And then whatever fraction is left over, it should be something from here to here or from here to here when you go through those. All right, now here's where we tie it together. For tangent, and we just said a minute ago that tangent is sine over cosine, right? So we're going to figure out what all these values are if we have to do tangent. Okay, so for pi over 3, tangent of pi over 3 is going to be sine over cosine. But sine is square root of 3 over 2, cosine's 1/2. All right, here's where we're going to save a little bit of work for this thing. Instead of rewriting it, how about we just keep it, change it, and flip it right here? So just make it square root of 3 over 2 times, flip this upside down, make it 2 over 1. Yep, cross out your 2's. And that leaves us just square root of 3. And that's getting really close to the secant part here, but it's okay. If we run into this box a little bit, we'll be fine. Okay, so is everybody okay with that one? Again, if you're going to do tangent, just go to that number that you have to do, figure out what the sine and cosine are based on where you are position-wise, and it's just sine over cosine. And it's 50-50. Sometimes you have to, after you keep change flip, you might have to rationalize it. This one, the square root was in the top, so that was okay. You didn't have to rationalize that. Okay, so if we do tangent of pi over 2, which is this number, again, it is sine over cosine. Sine is 1. Cosine is 0. It's 1 over 0. There we go. Undefined. If 0 is on the bottom, it's undefined. And that is the answer in that case. It's because if you try it on your calculator, again, I'm going to cheat because I'm going to use Casio. Actually, I'm not. I'm going to use a text instrument. If you do 1 divided by 0, it doesn't say undefined, but it says divide by 0 error, which is basically the same thing as undefined. Yeah. Yeah, and if you try the first one, if you go back and do that, if you do square root of 3, yeah, it's not going to give you the answer in. It's going to give you that. So that's where, again, for this test, you cannot use the Casios. You got to use these, which means you got to use your brain. When you get on the ACT or the pre-ACT or whatever you got next week, then you can use them, and then that way it's okay. Because that way it's just going to speed the process up. Yes, I have enough calculators for everybody. So. All right. All right. Now, if we do this one, if you notice on the next one, if we do pi over 6, the numbers are reversed, correct? So if we do tangent of pi over 6, and this one we're going to save a little bit of space so we've got room to work here. It's going to be sine over cosine, so that's 1/2 over square root of 3 over 2. And we're going to keep it, we're going to change it, and we're going to flip it. So that's going to be 1/2 times 2 over square root of 3. Now here's kind of the neat thing. I think we've got this back here. Oh, look at this. If we look back at the example we had before, back here, when we were practicing on these, we had 1/2 times 2 over square root of 3, right? We had that exact same problem. Imagine that. I came up with a problem we were going to use later on. What's the chances of that happening? Okay. So we've already got this worked out here, right? We actually worked this thing out on the previous example. So if we already know what this answer is, we don't have to work it out. We can say, all right, that answer is just going to be square root of 3 over 3. So if we need to kind of save space here, this is where we did the work back here. We kept it, changed it, flipped it to get here. We canceled out the 2's. Square root was on the bottom, and then we had to rationalize it to make it square root of 3 over 3. Okay. Again, that way we're going to kind of did that one on purpose so that we could save the room here. So we had it already worked out here to kind of go back and get that part. All right. So we do tangent of pi over 4. That's the square root of 2 over 2 over square root of 2 over 2. Yeah. But okay, that's the same thing over itself. So what happens when you put the same thing over itself? Yeah. That's just 1, right? Doesn't matter if that's 8 over 8 or 16 over 16 or -3 over -3. If it's the same thing over itself, it's all going to cancel, and we're just going to get a nice, easy 1. All right, if we do tangent of pi, it's 0 over -1. All right, we know 1 over 0 is undefined from what we said back here. 0 on top, then the answer will just be, there we go. The answer is just 0. Okay, now here's the great thing about the rest of it. If we do tangent of 330, that is sine over cosine. That's -1/2 over square root of 3 over 2. That's the same thing as right here, right? It's 1/2 over square root of 3 over 2. The only difference is one of them is negative. But if both of these numbers were positive, we don't have to work this out again, right? We've got the answer right here. Yeah, it's square root of 3 over 3 because we already did the work here for it here. Yeah, it's just in this case, it's a negative divided by positive, so just make it a negative. And somebody may be saying, so you're telling me you gave us the answers for every question? Yes, I did. Because once you go through a couple of these, there's only so many possible answers you can get from this. It's either going to be square root of 3 over 3, maybe positive, maybe negative. It might be square root of 3. It could be undefined. It could be 1. It could be 0. Let's see. So if we do this one, if we do the -45, it's the same thing over itself again, right? It's square root of 2 over 2 over square root of 2 over 2. The only difference is, again, one of them is negative. So instead of being positive 1, yeah, it's negative 1. So you've got the answer to every tangent question basically in your hands now. You can just have to kind of think about, all right, which one is it? And then just kind of set up and go from there. Same thing on this one. If we go tangent of -7 pi over 6, it's 1/2 over square root of 3 over 2. We did that right here. We know that answer is going to be square root of 3 over 3. But it's a positive divided by negative, so that should just be a negative square root of 3 over 3. Okay, so all these problems that once you do a couple of rounds, once you go through it once, every answer just repeats. It's just the same answer. Again, it might be positive, might be negative, but it's just doing the same thing.
Why is 8 negative?
Oh, because this was a positive and that was a negative. And if we divide a positive and a negative, it makes the answer a negative. Yep. So if there's one, if one of them is negative, when you do tangent, the answer will be negative. If two of them are negative, that's going to be positive. Yeah. Okay, and then for this one, if we do tangent of 720, that is 0 over 1, which is 0. If we do tangent of 13 pi over 2, it's 1 over 0, which is undefined. There you go. Okay, so it's just it's a cycle of answers. It's just figuring out, because there's only so many possibilities it can be. Some combination of 0, 1, some combination of 1/2 and square root of 3 over 2, or square root of 2 over 2. And that's the only answers you can get if we're going to do tangent. Okay, now you may be saying, all right, what about the rest of the paper here? Because we still got some more stuff going on. Okay, what are those words? Yes. Okay, so if you need to, if you've got room at the bottom of the page down there, hopefully you've got a little bit of room at the bottom. We've got 3 more operations. We've got SEC, which is secant.
Oh, wait, you've heard of this.
Yeah, some of you may have heard of this, some of you may not have. Depends on how far you got in geometry. All right, so for secant, it's going to be the same thing as 1 over cosine. All right, if we have secant, we also have cosecant. And the short for cosecant is CSC. It is 1 over sine. And then the last one is cotangent, which for short is just COT. It's 1 over tangent. Now, the good thing about cotangent, though, is instead of writing it as 1 over tangent, you can think about it as if you do 1 over tangent, you're going to do keep, change, flip thing. So really, instead of it being sine over cosine, it's going to be cosine over sine. Okay, so that's the 3 new functions that we're going to look at, but they're still going to use sine, cosine to get the answers for these. Okay, and again, because of these two, the way it's set up, we're going to have to do a little keep, change, flip, because they're always going to be 1 over this part. But the good thing is, with it being 1 over, there's a little bit of a shortcut with that part. We'll see if we can get there. All right, everybody good with those? Everybody got those written down there?
Yeah.
Okay. All right, so back to the front side. Okay, so for secant, we said it's going to be, just so we have to keep flipping over, that's going to be 1 over cosine. So if they ask you to find the secant of pi over 3, you've got to do 1 over cosine. Cosine is 1/2. So it's 1 over 1/2. And the good thing is, if it's 1 over 1/2, and this kind of, I think this is going back to Daniel's question there a minute ago, maybe. If you keep it, change it, flip it here. Now, the top part's never going to change because it's 1. You know, it's not going to do anything. And if you multiply by 1, does it do anything? No. So all we got to do really is just flip the bottom number, and that's going to be our answer. So in that case, it's going to be 2 over 1, which is just 2. Okay, so the secant and cosecant are there's a little bit of good news in there because it's always 1 over. All you have to do is just flip, take the reciprocal of the bottom one, and then work that thing out and get to go from there. All right, we're going to stick with secant for just a minute before we get to cosecant. All right, so if we're doing secant of pi over 2, that's 1 over the cosine, which is 0. Hey, look at that. We already know what that answer is. Because cosine's 1 over 0, that is undefined. There you go. So some of these answers will kind of automatically, just pop in there. Okay, so we do secant of pi over 6. That needs to be 1 over the cosine value, which is square root of 3 over 2. And this line didn't draw in very dark, so I'm going to kind of darken it in there. So that's 1 over cosine, which is square root of 3 over 2. And again, we're going to keep change flip it, but because of the 1 doesn't do anything. That just means we've got to flip the bottom part and just make it 2 over square root of 3. But we got to rationalize it, right? Because the square root's in the bottom. So then answer for that one is we keep the 2 there, move the square root from the bottom to the top, and just leave the 3 on the bottom. Okay. Everybody all right there? Everybody good? Okay. All right, so we do secant of pi over 4. It's 1 over, both of them are the same, doesn't really matter. Square root of 2 over 2, right? Okay, but again, the 1 doesn't do anything. We're going to keep change, just flip this thing over, make it 2 over square root of 2. And I think, hey, look at that. We also did this one back here earlier. Imagine that. I did 2 problems we were going to do ahead of time. How did that work? Just magic, right? All right, so if we have 2 over square root of 2, if we rationalize it, we take the square root from the bottom to the top, leave the 2 on the bottom. That way the 2's cancel out here. We just get square root of 2. So we can work this problem out, but again, through the magic of me knowing what the answers are ahead of time, we know this answer is just going to be square root of 2. Magic. Look at that. David Blaine's got nothing on me. Tell Penn and Teller to come on. I'll show him some magic. All right, so this one, it's 1 over negative 1. Well, that's nice, isn't it? 1 over negative 1, that's just negative 1. There you go. You're like, oh, can I please get some more of those? Well, you actually do get some more of those because on the next one, it's 1 over square root of 3 over 2. But we already did that one right here, right? So since we already did this same problem here, we've got the answer there. That's 2 square root of 3 over 3. So and same thing with these. All these answers are going to just keep repeating because there's only so many numbers that we can use to get what we're doing here. The next one would be 1 over the square root of 2 over 2. But we just did that one right here. That answer is just square root of 2. Because that's the same thing we've got right there. So if we've got it here, same thing there. And it's just going to keep repeating as we go through those. Okay, so that's, and again, we could keep going through secant, but it's going to wind up doing the same thing. If we do cosecant, the only difference for cosecant is it's going to be 1 over sine. But here's the great thing. It's the exact same numbers that we use for secant. Because in this case, cosecant is 1 over sine. Sine over here was square root of 3 over 2. But we just did that one right here, right? That's the same answer we used here. So instead of working it out, we know that answer is going to be 2 square root of 3 over 3. So the answers for secant and cosecant are basically just the same thing. It just depends on which number we're going to use there. Show which one? Number 8. Yeah, so for this one, for secant, it would have been 1 over negative square root of 3 over 2. But square root of 3 over 2 is right here, right? But it's negative, so instead of making this answer positive, just make it negative.
So is the one, so the one above it isn't negative because the other one's negative. Like the sin is negative, not the.
Correct. Yeah. Depends on if it's sine or cosine. It's negative. Yeah. Okay, this one gets even easier because this is 1 over sine. It's 1 over 1, which is just 1. So secant, cosecant. I know it's 1 over sine, 1 over cosine, but again, they're the same answers, just depending on where you are in the order pair and how you get there. So it's going to be the exact same answers as you go through these. Question.
So was the number
For this next one here, yeah, because it's 1 over a half. If you flip it, that's just 2 over 1, which is just 2. Yeah. Okay, so this is almost one of those things that if you, not that you're going to sit down and memorize all of it, but it's one of those things that once you do enough of them and you see what the numbers are, you kind of get in a pattern to know what the answers are going to be as you go through those. All right, and again, we can keep going, but it's just the same answers. And then we'll do a couple of cotangents and then we'll be done. So cotangent, again, is
on
secant, cosecant.
yes. Would it be negative 2 since it's 1 over the negative 1 half? Or is it positive?
For number 6, yeah, it's 1 over negative 1 half. So that would be negative 2. Yep. Oh, maybe just stretching. That's just a stretch.
No, I don't.
Oh, go ahead.
I didn't see 8. Was it negative?
Oh, yeah, it was just negative and then 2 squared 3 over 3. Daniel, question?
For COT, the tangent is undefined.
Oh, okay. So, all right, so let me get there. All right, so we're talking about number 2, right? So for cotangent, cotangent is cosine over sine. So instead of being 1 over 0, we're going to just inverse it, make it 0 over 1. Yeah, so just 0. Yeah, so the inverse of undefined would be 0, and the inverse of 0 would then be undefined. So they're kind of paired together if you want to think about it that way. For number 1, let me back up there. For number 1, it was going to be cosine over sine. So it's going to be 1 half over square root of 3 over 2. But again, don't redo all the work because you've already done that work. Right. Where is it? Right there. Yeah, number 3. That it's 1 half over square root of 3 over 2. We already did that when we know the answer is going to be square root of 3 over 3. So don't do all the work again. Just know that that's going to be square root of 3 over 3. So every answer that's in cotangent, you've already done it. In tangent, you just got to go find it. So you don't actually have to work it out. You just need to go see where it is. So if you do number 3, it's going to be 1 half. No, sorry. It's going to be square root of 3 over 2 over 1 half. But again, we already did that one on number 1. So I know this answer is just going to be square root of 3. Okay. So it's just a matter, again, of knowing which one. And again, everything spins off of being able to figure out what is sine and what is cosine. If you get sine and cosine, everything else is just a matter of, one over the other or 1 over one of those or whatever it's going to be there. All right, Sophia?
Can you do the cosecant for 7?
Yeah, cosecant for number 7. All right, so cosecant is 1 over sine. So that's 1 over negative square root of 2 over 2. So same answer that's here, right? But it's 1 over a negative. So just make that answer a negative and then square root of 2. Yeah, so if this answer was just 1 over the positive number, if this one's 1 over negative, just make the answer negative there.
Why didn't we do 1 over tangent?
You could do 1 over tangent, but if you think about it, it's because cotangent is, if it's 1 over tangent, it's the same thing as cosine over sine. And that way you don't have to worry about doing any keep, change, flip. That basically whatever the number, and once you set it up here, it's got to be one of the answers that you've already got here. So you could do it that way, but the way we get, as long as you got this kind of out in front of you, it'll make it easier just to think about it being sine over cosine, or cosine over sine in that case.
Is number 4 cosecant?
Number 4, cotangent would be 1 over square root of 2 over 2. Oh wait, I'm sorry. Square root of 2 over 2. Over square root of 2 over 2. Yeah, that's the same thing over itself, right? So yeah, just 1.
Can you do the cotangent